This video gives high-level overview on traditional deployment, virtualization, and containerization. You have an application that you want to deploy. To do so, you first need to provision and manage the entire infrastructure. This includes networking, storage, server hardware, compute resources, operating systems, runtimes, and all the necessary configurations before your application can run. Security must be managed at every layer. Once your application is deployed, you notice that resource utilization is quite low. But when you need to deploy another application, you often provision additional infrastructure and repeat the deployment process. Similarly, separate environments such as development, staging, and production require their own dedicated resources. As your application's popularity grows, you need to scale it. This means provisioning additional servers. Over time, the number of servers continue to increase. When traffic decreases, imagine downsizing this. This traditional approach comes with several challenges: high operational cost, slow provisioning, inefficient resource utilization, limited scalability, and significant infrastructure management overhead. Virtualization made infrastructure much more efficient. In powerful physical server, you install a hypervisor that allows one physical machine to host multiple virtual machines. Each VM has its own network, CPU, memory, storage, and its own operating system, providing strong hardware-level isolation. Now, multiple applications can run on the same physical server, significantly improving resource utilization and reducing infrastructure cost. Since VMs are essentially files, you can create snapshots and restore them when needed, migrate VM between hosts, clone environments quickly. Managing development, staging, and production environment is much easier. Scale infrastructure more easily compared to physical servers. However, virtualization still has limitations. Each VM requires a full operating system, which consumes additional CPU, memory, and storage resources. VM provisioning takes minutes. Startup times are relatively slow. Managing large number of VMs can become operationally complex. With process-level virtualization, containers took efficiency to the next level. Application code with required libraries and dependencies is packaged into an immutable blueprint called container image. To run containers, you need a host, either physical server or a virtual machine, with a container runtime like containerd. The container image is used to create and run one or more containers. Multiple containers share the same host operating system kernel while remaining isolated from one another. Containers use kernel features, namespaces to provide isolation, and Cgroups control and allocate resources such as CPU and memory. With containers, developers can build once and run anywhere, ensuring consistency across development, testing, and production environments. Provisioning and scaling becomes fast, application deployment becomes easier, and resource utilization improves significantly. Containers also integrate naturally with modern CI/CD pipeline, enabling rapid, reliable, and repeatable software delivery. However, as the number of containers grows, the challenges are managing networking become complex, scaling based on demand becomes complex, service discovery gets complicated, keeping application highly available gets challenging, load balancing is required, orchestration platform like Kubernetes is required. Quick recap. In traditional deployment, applications run directly on a physical server with the host operating system. In virtualization, multiple virtual machines run on a single physical server. Each VM has its own guest operating system. In containerization, multiple isolated containers run on a shared host kernel. Thank you for watching. If you like this type of content, consider subscribing to this channel.